Hello, my name is Soren. I'm the product manager here at Data Technologies. I want to present to you the Data Count U162 on top of an Autobag PS125. This is a new product, and this movie will be used to present this product to different Autobag partners and distributors worldwide. First, what is the system or the way we count? Okay? We count in a way we call bulk counting. It's the ability to count multiple objects as they fall. Okay? Traditional counting, you may know, you can use a ball feeder, feed them one by one, count them. You can use a multi-channel, feed them one by one, count them. We are the only company in the world that implemented this unique technology that enables counting of multiple objects, more than one object, in the same time while falling. Okay? This is the feeding track. This is the counting unit. Okay? Everything that falls through the unit is being counted. Okay? The counting is done from 360 degrees orientation of CCDs and lasers. Why we use 360 degrees is to prevent the following situation. Two objects, okay, if you use one orientation you will see one, and from the other two orientation you will see two. So we know these are two objects, okay? This is why we use this kind of sampling. We sample at rates of more than 3,000 frames per second, okay, in order to reach the accuracy of the count we provide, we promise. So the system is built out of the following subsystem, subunit, call it as you wish. Okay, we have two feeding tracks. The back one purpose is to prevent blockage in the hopper. Okay. So the back one is feeding objects 1, 2, 3 layers to the front feeder. The front feeder, okay, conveys the objects into the counting tube. Okay, the objects fall through the tube. Here we have two flaps. Okay. This is used as a storage unit, as a memory unit, storage unit. The objects are being counted here. If the count is a good count, they are released into the bag. If the count is a bad count, it is released into the reject station. Okay? Beneath, you have the PS125 unit, you already know. And the objects are being counted into the bag, sealed, the bag is released. Okay? Now, in order to check that the bag is open, we have also the following, can you close up please? We have the following bag sensor. Okay? This bag sensor is a distance sensor. It can detect both solid and transparent bags. You need to position it in the farthest possible distance of the bag, and as it's very visible, okay, we check only at the bottom of the bag, okay? Because of the sealing, we are not able to position the sensor on top, okay? Only below, so it will work 60% of the time, not in 100% of cases. This is the normal PS125 unit you already know. You have the manual mode, okay, working. Okay? Now on the factory defaults, you need to enable the Ethernet connection. Okay? Once you enable Ethernet connection, you will have the following, if you can close up please, here. You have the following new option. It's called beggar connectivity. Normally it's offline. We want to make it online. Okay? I will press it. Press one time start. One cycle. Okay, and now you will see a blinking message which is called infeed wait or reset. Okay? This means that this machine is now in a connectivity state with another machine. In this case, this is our machine. Okay? The connection between both machines is one RS-232 connection between the data machine and the Autobag machine. The plug itself should be configured in the Autobag factory prior to shipment. Okay? This is not a standard plug of Autobag. Special details about this you can ask us personally and we will help you with this, but you need to make slight adjustments in the PS125 machine in order to receive the cable. Once everything is set, once the system is set, next thing I want to also show you, basically is the device configuration and check. Okay? Tabs 3 and 4 are Autobag tabs. Okay? Here you can see the following section. The first section is back feeder. Okay, you have an output and input bit. Normally it's 1 and 1. Here you can check by pressing and releasing the bit. Okay. You can see the cycle is working. Okay? The connection, first of all, is okay. Second thing is the back sensor. Okay? Back sensor, we have the bit. Here it senses. Okay, in this position it senses. The ideal position is that I take it to the farthest possible position until I find the detection. Okay, here I have a detection. This is the standard position. Opening delay means what is the time in milliseconds I need to wait before I release a good count to the bag. If you have a problem inflating the bag or opening the bag, you can put a relatively large delay to allow you time to open the bag for the PS machine. Retry on failure, this is on the automatic mode. Basically what we say with this option is if the bag, the sensor didn't detect a bag, I will try another cycle of a bag opening. If this doesn't work, I will try another cycle. The number of cycles are configured by the user. It's a system configuration, okay? This is to enable the automatic of the bag and not stopping in each time I have a bag opening issue, okay? The funnel option, okay? We have two options, okay? This we call a flap mechanism, and we have a funnel mechanism. A funnel mechanism basically is that I drop with a funnel, with a dipping funnel into the bag, okay? The bag sensor is on the funnel, okay? Once I detect from inside that the bag is open, I pull down, okay? This is used mainly for very small and light objects, okay? This is the funnel option. Currently, as you can see, it is disabled. The flap option, okay, enabled. Here again, I want to check, if you can show there, I want to check, okay, that the flaps are working fine. If not, you can make some adjustments with the air, with the pressure for the piston, and that's it. That is the system. This is first step in system configuration. Okay? Second step, we want to define a new object. Okay? In order to define a new object, let's create a new object. I will call the new object, I don't know, APS. Okay? Here we have an automatic way of setuping a new object. Okay? First stage. Okay, at the first stage, we need to set whether we use, only one feeder, this is an option, or two feeders together. As you can see, I have two feeders, so I will check the back feeder frequency on. Okay? In terms of frequency, the higher you get, the less speed you have. Okay, it's the opposite. So I will start with a very slow configuration of the back frequency. The front frequency, I will keep it as is, in the meantime, okay? And I will press the test. Once I press the test, you will see now, can you look at it? Okay? Now, what you see here, okay, I use the back feeder in 2-3 layers, very slow. This front feeder must be faster than this one in order to have separation of the objects. And we only need to take one thing into consideration, which is that we need to feed into the detection unit in one layer. So if I see, okay, the layer is okay, I can continue to the next step. I will run again the test. Okay? You see here I have good separation, I have one layer. I can continue to the next step. Okay. Second step is the size calibration. Now, here you can see, can I see it? So here you can see these are small glasses parts. Now, we started by working with organic materials, so it's okay if the parts are not completely the same. I need enough objects in order to feed them to the counting unit. The counting unit samples the objects and gives me a range, a minimal and maximal size of the objects. Okay, everything that meets the criteria is being counted. So all you need to do is press the start calibration. Here you can see the sample. I will not do this until then, but normally around 10,000 objects are enough for this stage. I got a minimal size, a maximum size, done, this is approved. Next thing, okay? Next thing, this stage is for the automatic, the target count, okay? These are parameters that control the target count. Again, automatic, I set a quantity. I press the auto calibration button. So. Okay, and basically I start a cycle.
לא הפוך. לא רואה, החלק העליון הוא עם האור.
Okay, so now the automatic calibration of the target count is stopped. I have specific settings. I first do a test, okay, to make sure it's counting to 100. Okay, you see I have a slight over, so I need to make some manual adjustments. Okay, first of all, the extra pulse length, I will take this lower and try again. Okay, still I have a bit of an issue. I will stop. Now you see that the extra pulse length is now too slow. Okay. The extra pulse is too high. Okay, this seems okay. I will try another time. Okay, seems okay. If we need to make some slight adjustments later, we will do this. Okay, so this was the new object setup. I finished calibrating this new object. Next step, I need to choose, okay, the objects. It's called what was the name?
APS אולי?
APS. Okay, I choose the APS product. Number of objects per bag, I'll set it at 120. Number of bags, set it to 20, so we have some time looking at the machine. And now I can run the machine, okay? את יכולה עכשיו להתרחק. טיפה לעצור ונקצר. Why you need to use the machine, okay? Now, this is a 60 millimeter thread, okay? Now, the point is that if you use small objects, or let's say the ratio between the width of the thread and the size of the object is a good one, it means that many objects can be counted at once, can be fed at once. In this situation, you can see that in each given moment, okay, more than 8 objects fall together, okay? This affects directly the speed. Now if I take this object and I'll multiply it, let's say I put here a 30 millimeter object, they will be fed one by one. Hence, the many advantages of the bulk counting are non-existing. So first of all, the objects needs to be, compared to the track, smaller. You need to feed several objects at a time. This is the first condition in object choosing. The second condition is that the more I count, the bulk counting is more effective. If you want to count 3 objects, 5 objects, you will get the same speed by using a ball feeder. If you want to count 15, I will be more effective. If you want to count 500, you will have no other solution in the entire universe that can meet my speeds. The more I count, the more I reach levels of speeds that are very much similar to wave, okay? So basically, if you have a small object that is now being weighed, you can offer this solution, tell to the customer, now you can count the same object, relatively very similar speeds, but instead of giving weight assessment with an overfill of 2 to 5%, you can have 99.98% accuracy counting to a bag. Okay? This is what we offer. You don't need to offer this solution to someone that wants to count 1 object, 2 objects in a bag. This you can do with other types of technologies. Okay, this is our technology, this is what it does best. Let's go back to the machine. Different ways of working. Again, we believe here at Data building products that are versatile. Okay? I don't want to decide for you how to use the machine. So we have different types of uses, and you need to match the use to the customer. Okay? First thing, we can use this machine in a manual way. Okay? Okay, now the empty bags you saw cut. Okay, these bags are because we enabled the retrial failure option before, if you remember. It means that the bag sensor didn't detect the bag, so I cut an empty bag and try another cycle. Okay? If I take the bag sensor closer to the bag, I will have less of these things happening, situation, but I will have more problems when the bag really didn't open. Okay? So, this is the manual. What is the manual? Basically, I'm the operator. I tell the machine, okay, you move to the next bag. I count another bag. Okay? This is a manual mode. This is a manual mode. Now, when You can use the manual mode by pressing next, or you can use this foot pedal, which basically does the same. Okay, I press the foot pedal, I have a count. Okay, and I have another cycle again. Okay, this is one option. Second option is an automatic mode. Basically, we enable you to work on a fully automatic way. Okay? What are the constraints? Okay? We know about our machine, our technology. You should know about your machine, your technology. You know how to match the bags. You know what are the constraints in the opening. If you have a bag that you say, okay, this bag 95% of the time it opens, okay? You can use an automatic mode, okay? How you use an automatic mode? Basically, you have an automatic button, you press the automatic button, and now I start working in an automatic way. Okay, I have 3 cycles of bag that I didn't detect opening. I start the session. Now, again, as I told you before, I can take the sensor closer. If I take the sensor closer, I will have less of these things happening, but you will have more chance not detecting an opening bag because I only settle the bottom bag, not the upper one. Okay? I will continue. Okay, this is an automatic mode. Basically, the machine can run. You will have, again, some empty bags, cuts. This is what you need to take into configuration. But the machine can work automatically. And now you have a fully automatic machine. Okay. Now, again, it's important that you see this also. You see that the back sensor is not 100% working, okay? I will take this. Okay, so again, I showed you before the manual mode and the foot pedal mode. Now we can open a fully automatic mode. Again, I remind you, every time I don't detect the bag opening, I will cut it. After 3 times I stop. Okay? Second thing, you are aware of the constraints of the bags. If the bags, you can say for sure they will open 90-95% of the time, an automatic solution, automatic mode will be perfect. If you know this is a problematic bag, you want to count, I don't know, heavy big objects into a very small bag, and you know that you have problem with the opening or with the filling or whatever, maybe a semi-automatic is more suitable. Okay? So this is the automatic mode. here you saw I have no detection. So this bag is an empty bag, okay? But again, the machine continues working. Okay, now if you see you have too many of it's empty, like you see here, again I can take this mechanism further closer to the bag. You can have, okay, here I had a reject, 125 count by accident, was rejected, put them in the tray. Okay, now once I finish a batch, I can get statistics of the batch. Okay, 20 accepted, 2 rejected. I haven't allowed overfill in the count of 1. You can choose to have it 0, but this is the configuration of this program. You also have details per bag, when was it counted, what was the count, if it was rejected, why, and there on the right you can see again the reject tray. These can be, of course, you can put them back in the silo and pack them again. This is not waste, only count reject. Okay, so this was the batch mode. Okay, second mode you can use is a table count. Basically here you can upload an existing Excel file or create a new file from here. I will just give a short example. Okay. For example, I want to count two bags of 100. Okay, let's say I want to prepare an order. I have 2 bags of 100 and I have 3 bags of 130. Okay, now you can see here in the table itself I have 2 counts of 100, 3 counts of 130. Of course, I can add more columns, I can have more description, I have barcode options, I have many options that are, we can talk about them later in great detail, but the main principle, you can create a work plan or upload a work plan for inventory, for companies that pack per order the same object or different types of objects. Okay? So if I want to start again, like before, I have a manual option and I have an automatic option. Okay, manual option, I choose the starting point, and I have a count. Okay, very simple. Again, the foot pedal. Okay, for the second bag I can use the foot pedal, count 100. I have an overfill of 1 allowed. For the third option, okay, I can also use the foot pedal. For the third line, sorry.
לא, אבל הסתכלתי על הפדל, לא על ה...
Okay, and for the last two, I can use an automatic mode. Was rejected. Okay, this was accepted into the bag automatically. That's it. I press done. Finished my work for today. Thank you very much.